Let's understand Earth's energy and matter flow in this video. Have you ever wondered why the sun feels warm, but a snowy mountain stays cold? This video will take you from sunlight to rivers, winds, and life on Earth.
Life on Earth depends on energy from the sun and matter that keeps moving around. The Earth is made of interacting parts we call spheres, like pieces of a puzzle. First, the geosphere is the solid part. Rocks, soil, and landforms like the Deccan Plateau and the Thar Desert. The hydrosphere is all liquid water, from the Ganga River to oceans and groundwater. The cryosphere is frozen water, like Himalayan glaciers, snow in Ladakh, and polar ice caps. The atmosphere is the air we breathe, cleaner in mountains and forests, and it surrounds the earth. The biosphere is all living things, from mangroves and forests to plankton and coral reefs. These spheres talk to each other, so a change in one can change the rest. For example, warmer Arabian Sea water can make the monsoon stronger in some places and cause drought in others. The sun sends energy as electromagnetic waves moving at the speed of light. Some waves like gamma rays and X-rays have very high energy and are harmful, but most are blocked by the atmosphere. Most of the sun's useful energy comes as ultraviolet, visible, and infrared light, which heat the surface and help plants grow. The ozone layer soaks up much of the harmful ultraviolet rays and keeps life safe. When the ground warms, it sends heat back as infrared, and greenhouse gases like carbon dioxide, CO2, methane, CH4, and water vapor trap some of that heat. This trapping keeps Earth warm enough for life, but too much CO2 causes extra warming. Insolation is the sunlight that reaches the surface, and the solar constant at the top of the atmosphere is about 1.4 kilowatts per square meter. On a clear day, the surface gets about 1 kilowatt per square meter, which is a lot of energy. For example, 1 square meter receiving 1 kilowatt for 1 hour gets about 3.6 million joules of energy, enough to do real heating work. Different surfaces react differently to sunlight. Dark roads heat up faster, while snow reflects most light. The fraction reflected by a surface is called albedo, and snow has very high albedo, keeping polar regions cold. Cities heat up more than nearby countryside because concrete and asphalt absorb and hold heat, creating an urban heat island. The round shape of Earth makes sunlight hit places at different angles, so the equator gets concentrated light and poles get spread out light. This uneven heating makes temperature differences that drive winds and ocean currents. The atmosphere has layers, and the lowest layer, the troposphere, is where weather happens, and temperature falls with height. The stratosphere holds the ozone and warms with height, which keeps weather mainly below it. Local winds like valley breeze and mountain breeze change daily in hilly places and help move air and moisture. Wider planetary winds form because warm air rises at the equator and sinks near 30 degrees latitude, making belts of wind that move around the globe. The Earth's rotation makes winds curve to the right in the northern half and to the left in the southern half. Oceans also move in currents driven by winds, temperature, salinity, and land shapes, forming circular gyres. Currents carry heat from the equator to the poles, and the North Atlantic drift keeps parts of Europe milder in winter. Now about matter. Living and non-living parts cycle nutrients in biogeochemical cycles, so life gets what it needs. The water cycle moves water by evaporation, transpiration, condensation, precipitation, infiltration, and groundwater flow. Climate change makes a warmer air hold more moisture, which can mean heavier rain in some areas and drought in others. Carbon cycles fast when plants and animals exchange CO2 in days to years, and slow when dead matter becomes fossil fuel over millions of years. Human burning of fossil fuels and deforestation raised atmospheric CO2 from about 315 parts per million to 420 parts per million since 1960, roughly a 35% rise. The nitrogen cycle turns unusable air nitrogen into forms plants can use through fixation, nitrification, assimilation, ammonification, and denitrification. People also fix nitrogen industrially in the Haber-Bosch process to make fertilizer, which change farming but can pollute rivers. Oxygen is used in respiration and combustion and is restored mainly by photosynthesis in plants and plankton. Human activity affects these cycles, causing problems like ocean acidification, algal blooms from excess fertilizer, soil erosion after deforestation, and unhealthy city air. Global actions like the Montreal Protocol help the ozone layer recover. And steps like switching to solar energy, planting trees, and saving water can restore balance. So, what do we learn from this? We learn that energy from the sun and cycling matter keep Earth alive. And small changes in one part can affect the whole planet. Let us quickly remember. The sun powers weather and life. The atmosphere and oceans move heat, and water, carbon, nitrogen, and oxygen keep cycling. So today we learned how spheres, sunlight, winds, currents, and cycles work together and how people can help keep them healthy. Keep asking questions and explore more to see how these ideas connect to your life and your town. Learn more on EduRev, where you can find friendly lessons and practice at your own pace.